So with part 5, some people think that logs are the most difficult. I know for many of us in here, we still are unsure in some ways of how to deal with trigonometric functions, and it mostly comes down to memorizing the unit circle. So we're going to take a little bit of time. We're going to go through all of the trig that I need you guys to know for this class, and hopefully clarify some key ideas. So what I need you to know is when we are looking at the unit circle would be a circle centered around 0, 0 with a radius of 1, hence the word unit, radius 1. When we are identifying values along the unit circle, I want you to think that the x-coordinate would be equivalent to the cosine value, and the y-coordinate would be equivalent to the sine function. And the reason why is if we drew a triangle with a radius of 1 and we were looking at this base angle, we're going to call that theta. If we looked at x and y and we were trying to relate them to the hypotenuse, sine of our angle, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, is y over 1. So along the unit circle, sine is the y value. Likewise, if we did cosine of theta in our picture, it would be x over the hypotenuse, which is 1. So cosine is the x value, if you remember your SOHCAHTOA. So what we are going to do is we are going to count the angles, and then we're going to write in the values of the coordinates. So first, we can either count in degrees or radians. And radians is just talking about the angle in comparison to 2 pi in terms of its circumference. The other is 360. So if we go around a circle one whole revolution, that would be equivalent to 360 degrees. In radians, it would be equivalent to 2 pi. And now what we do is we go, okay, cut that in half. If you go halfway around the unit circle, we would take half of 360, which would be 180. If we take half of 2 pi, we get pi. Again, going by halves of things, if we take half of 180, we get 90 degrees. Half of pi is pi over 2. Like we could also do on the other side, halfway between 180 and 360 is 270 degrees. Halfway between 1 and 2 is 1.5. So we write 3 pi over 2. So now we have all of our quarter marks. And what I want to do is take half, again, of pi over 2, where half of 90 degrees is 45. And half of pi over 2 is, half of a half is a fourth, so pi over 4. So now we're going to count by 1/4. So if you stay with me, 1/4, 2/4 is pi over 2, 3/4, so we have 3 pi over 4, and 4/4, which is 1 pi. Again, halfway in between would be 5/4, or 5 pi over 4, 6 pi over 4, which is 3 pi over 2. And last one is 7 pi over 4. That is just strictly counting in quarters. If I did the matching degrees, we would have 45, 90, then another 45 is 135, and then another 45 is 180, and then another 45 is 225, 270, 315, and then 360. So we're just dancing around the unit circle, filling in the values. The second value that we are going to look at is we're going to take 1/2 and divide it by 1/3, because we have 3 equal pieces. So when we do that, half of a third of a half is pi over 6. or 90 divided by 3 is 30. So in this case, we'll start counting by 30s, and then we will do the fractional count. So if we go 30, then 60, then 90, then 120, and then 150, then 180, then 210, 240, 270, 300, and 330. Again, just working our way around the circle. So if we are counting in sixths, so we would have 1/6, which is pi over 6, and then 2/6, which is pi over 3. The next angle would be 3/6, which is pi over 2. 4/6, which is 2 pi over 3. 5/6, which is 5 pi over 6. 6/6, which is pi. 7/6, we have 8/6, which is 4 pi over 3. 9/6, which is 3 pi over 2. 10/6, which is 5 pi over 3. And 11/6. This is how we can easily work our way around the angles in the unit circle. Now, why are we focusing on these specific angles? Well, if you think back to geometry, we have two special right triangles that make our lives a lot easier. First one we have is a 45-45 90-degree triangle, which is the legs are the same and the hypotenuse would be the side length times the square root of 2. The other type of special right triangle that we deal with on the unit circle is a 30, 60, 90 triangle. So in this case, we'd have 30, 60, 90. And we often say that the hypotenuse is 2x. The side opposite 30 is half of that, which is x. And the side opposite 60 would be x root 3. So these are review, but these will help us identify the values that are in the ordered pairs. If you ever get stuck, just think all of the ordered pairs are going to be square root of a number divided by 2. And we will actually go over in class a hand trick that you could utilize to know this. So I'm just going to draw in this first triangle that we're looking at for you to see that we are dealing with triangles. So this base angle is 30. Our hypotenuse is 1. So if we took half of 1, we would get the x value, which is 1. Sorry. The angle here is this base angle. So the side opposite that is 1/2. That is our height. So our height is root 3 over 2. Our length is square root of 1 over 2. Now we generally don't write the square root of 1 because it's just 1. That is how you find these values along the unit circle. I contend that if you know the first quadrant, you get everything else for free. All you have to do is be able to change signs. So the angles at pi over 3 or 60, the ordered pair, would be root 3 over 2, comma 1/2. At 90, it's 0, comma 1. And now we are just going to change the values. Because if you remember this, everything is positive in the first quadrant. Sine is the only trig function that's positive in the second quadrant. Tangent is positive in the third quadrant. And cosine is positive in the fourth quadrant. So all students take calculus. I'm going to fill in these values where in the second quadrant, the x values are negative. The y stays the same. Let's make sure that Mr. Swenson writes these correctly. This x value is root 3 over 2. The y value is 1/2. Here, the shorter value should be the x value, which is 1/2. The y value is root 3 over 2. My fault. And now we go to pink. We have negative the x value, negative 1/2, positive y value, root 3 over 2. Negative root 2 over 2, positive root 2 over 2. Negative root 3 over 2, positive 1/2, and then negative 1, comma 0. Then in this third quadrant, we have a negative x and a negative y. So negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2, then negative 1/2, negative root 3 over 2, and then 0, negative 1. Fourth quadrant, the x values are positive, the y values are negative. So 1/2 comma negative root 3 over 2, then root 2 over 2, negative root 2 over 2, then negative root 3 over 2, 1/2, and finally we are back to 1, 0. I have a thing up on Schoology that will help you guys memorize all of these values, and it's key. So when we are asked to evaluate certain values, all we have to do is be able to identify where we are located on the unit circle. So if you will, the cosine of pi over 3 is asking what is the x value at the given angle. So 3 pi over 4, we go to 3 pi over 4 up here. We look at the x value, it's negative root 2 over 2. So our answer is negative root 2 over 2. Done. The sine of 7 pi over 6 is saying, what is the y value at 7 pi over 6? The y value is negative 1/2. Tangent is, what's the tangent value? Tangent is opposite over adjacent, or the y value over the x value. So if we go to 5 pi over 3, we go, what is the y value? Negative root 3 over 2 divided by, what's the x value? 1/2. The 2's cancel each other out, and we are left with negative square root 3. To undo trig functions, we are asking at what angle do we get this value? Now, it's important to know that each of the inverse trig functions are restricted. So inverse cosine only exists in the first and second quadrant, while inverse sine exists in the first and the fourth. Now, we can talk about it in a little bit as to what these values actually are, because they're not touching each other. But what I want you to be able to do is look at the second quadrant. Where is the x value? Negative 1/2. That would be 2 pi over 3. Where is the y value? 1? Well, that would be at pi over 2. And where would the y value be negative root 3? Well, we already found that, which is 5 pi over 3. Now, technically, the answer is negative pi over 3, and that's because inverse sine and inverse tangent have domain restrictions. We will talk about the restrictions in class as to why those happen. So we're going to stop here. We're going to do a little practice, and then we are going to come back to other properties of trigonometric functions.